All right, guys, what's up today? Trying to get you guys caught up on some simplifying radicals. Basically, what I'm going to do is I'm going to use one video, but I'm going to break it down into 2 days, kind of how we're going to do it in class. Really, what we're going to focus on the first day of class is this prime factorization calculator. And what you'll do is you'll be able to find the prime factorization calculator on your Google Classroom. There's a link there. All right. So kind of what you're going to do is you're going to use this prime factorization, and then we're going to be able to break down these radicals into more simpler terms. Okay, so for example, on A right here, if you type in 625 onto your prime factorization calculator, it's going to give us 5 times 5 times 5 times 5 times 5. So what we'll do is we'll rewrite this radical as such. So it'll be 5 times 5. It's going to take me a second because I got mine. Now, it's kind of like we've been doing in the past, even with variables, okay? Our radical, or the important part of our radicals, our index here. Basically what this 3 is telling me is I'm looking for a grouping of 3 of the same numbers, okay? So I'm only going to circle 3 of the same numbers. So for example, we have 4 5s here. So what I do is I would just circle the 3 of the 5s. I'd leave the other 5 alone because it's not part of the other one, okay? So what's going to happen is you would rewrite this now as 5 because, again, the cube root of basically 5 times 5 times 5, which is 125, is 5. Okay, now what happens is whatever is left over or does not get circled, you're going to put on the inside. So the simplified version, the cube root of 625 is 5 cube root of 5. Okay, now moving on to the next one. All right, so 540. Okay, again, since it is a 2 right here because it's missing, all right, you're looking for groupings of 2 of the same number. So when I write this out, okay, it would be 2 times 2 times 2, or 2 times 2. And then it would be times, it looks like 3 3s and a 5. All right, so again, I'm looking for groupings of 2. So I notice right here, my 2s have a group of 2. Also, I have a group of 3s. So this is a little bit different than what we had before because we didn't have 2 groupings, we just had 1. So when you have 2 groupings, you would multiply the 2 numbers here. So it'd be 2 times 3 would give me 6. Okay, because again, what's the square root of 4? Well, we know it's 2. What's the square root of 9? We know that's 3. So it would be 2 times 3 gives me 6. And then whatever is left over, again, it's 3 times 5. So this would give me 15. Okay, that's kind of how you do that. What I'm going to go ahead and do right quick is now show you guys a couple more on a different page. That way you can go ahead and get a couple more problems done. So let me flip pages right quick. Okay, so now we're actually like on the daily work page, so this way you can at least get some questions done here. So we'll start over here with number 3, and then you would put 162 into the calculator, write out the prime factorization. So it looks like it's going to be 2, and then it looks like it's going to be 3 times 3 times 3 times 3. I'm just going to put dots this time instead of the x's. You can do either way, it's fine. So again, I'm looking for a grouping of the same number that has 4 numbers. So for example, I would circle all my 3's right here. So my answer here would be 3. I forgot my little 4 right there. Don't forget that, that's important. Then it'd be 3 4th root of 2. Now, A lot of kids get confused. These are not multiplied or nothing. This is the 3 is actually in front of the radical here. It's just kind of hard to draw on the paper. Okay. So that's kind of what we were going to be focusing on for today. What we'll do for tomorrow is now, and I'm just going to stay on the same page and just kind of teach off this page. But what we're going to do tomorrow is we're going to now add the variable and the numerical part together. So if you notice down here, you have numbers and you have variables. Okay. So I'll do one that kind of covers all the aspects, which is number 12 right here. It kind of covers everything. So basically what you're going to do here is you take your radical and everything. So the 200 is separate from the R, which is separate from the S, which is separate from the T. You're going to do all 3 of those kind of in separate problems. So what I'll do is I'll just kind of do those over here to the side. So the first thing I'll do is just the square root of 200. So you'll do the same way we just did that. Okay, so I'll go type in 200 into our calculator. And I'll calculate prime factorization. So it's 3 2s and 2 5s. Trying to get my multiplier sign right there. And it would be 2 5s. Again, this kind of goes back to that example we did earlier. Okay, I'm looking for groups of 2s. All right, so now I got 2 times 5. So this is going to turn into 10. And then I'll keep my square root of 2. Okay, now I take my R8. Okay, and if you guys remember what we did before the COVID break, we would divide R8 divided by 2. That's going to give me R4. And I'll take my S, do the same thing. Now, this is where it kind of becomes new. All right, what you're going to do here is you're going to figure out how many times 2 goes into 3. Well, you should say, okay, it goes in there 1. So I can know I can type S1. But what you do is whatever the remainder is, and in this case, it would be 1 as well, that goes back underneath the radical. Now, T you don't have to worry about since it's already 1. It's not going to divide, so it can go ahead and stay under. But I'll go ahead and show it. If you ever get a variable that has a 1, it will never come out. Okay, or one that you get that's smaller than the number on the outside, you would just rewrite that T1 or T back inside. Okay, now to put this all together, we would go ahead and start with the number first. So it would be 10. Then I would go R4. Then I would go S1. And then I would do my radical and then write everything radical wise. So I would go 2. There wasn't anything for the R, so the R wouldn't go back underneath. But I do have an S1 and a T1. Okay, it's a little confusing at first, but once you get the hang of it, it's not too bad. All right, let's do one more of these. Let me see if I can find one that doesn't have that doesn't break down. I think maybe the oops. Okay, so the first one, actually number 8 will work good. Okay, so what we can do on number 8 here again is figure out again what our number is, 375. That's going to turn into 3 times 5 times 5 times 5. And I'll just go ahead and write that out to the side. 3 times 5 times 5 times 5. Again, don't forget your little cube right here, cube root. So again, I'm looking for a number that has 3 of the same numbers. See, that's 5. So this will turn into 5 cube root of 3. Okay. Now, I do the same thing for my W like I did earlier. So what you can do is it'd be 32 divided by 3. Now, what I could show you guys what to do is you could do old school division. you wanted to, just to kind of figure out what you're going to need to do. So I'm going to show you kind of the old school division. 3 goes into 3 one time, so I'll put 3. So I get 0, drop down my 2. Okay. 3 doesn't go into 2, so I'm going to replace this with a 0. And then so I can put 0. So I'm going to have a remainder here of 2. So what's nice about this way, if you're not sure how to divide or how to kind of figure it out, what's nice about this is it's going to go ahead and tell us what goes outside and what goes inside. So like on this W right here, it's actually going to be W10, because that's what we got for a whole number. So W10, and then I would have the cube root of W2, because that was my remainder. So basically like your cube or your radical symbol is kind of like what your remainders would be. So how I would write this out, it would be 5 W10, because again, do my numbers first. Then I'm going to write my radical because that's all the numbers I have. Then I go back and do my radicals. So it'll be 3 and then W2. So it looks real complex, but once you kind of break it down and kind of see what's going on, it's really just some circling and just kind of figuring out what your groupings are, and then just some old school division to kind of figure it all out. And that's kind of what we're going to be doing for the next couple of days. So if you guys have any more questions, just let me know. I mean, there's some other examples that happen, that things happen, but hopefully you guys can figure those out. And again, if not, I'll go ahead and do one more just to help out. So like, for example, these type right here, why I didn't do one like this is because what will happen is here, all those variables will actually reduce. So like x to the 5th divided by 5 is just going to give me x now. Y15 divided by 5 is going to give me Y3. And then Z45 divided by 5 is going to give me Z9. So sometimes you're going to be able to do these problems and you won't have a lot of work, and there won't be any radicals left. Sometimes you will have radicals, sometimes you won't, just depending on how everything simplifies down. So I appreciate it, guys, and hope you guys have a great day.